a hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others.
I said true.
I put true as well. Yeah.
That's just from the reading.
Yeah.
And for the next one, I have the last two. And that's the reading as well.
So I know that the ANOVA can't have any negatives, so the first one isn't right as well.
Yeah, I don't know why, but it's just the second two.
Okay. Yeah, I had all three of them marked, but
because I know it can't have negatives, but I don't know, maybe because it's worded that way.
Like, I thought about that when I read it. I thought, that's weird.
Yeah.
Okay, number 5, I put construct a QQ plot for each group.
Yep.
And we assume the variance in each group is the same if the following happens.
So this would be the largest variance is less than 4 times the smallest variance.
Right, that's what I have. Okay, and then ANOVA hypothesis for 7, I got 8 different.
I have 6. So if you look at like I had to count it on my hands. So I did 1 to 2, 1 to 3, 1 to 4, and then it'd be 2 to 3, 3 to 4, and then I'm missing one more. There's one more.
Yeah, there should be, you don't test 2.
And then 2 to 4. So I have 6.
You're right. So
sorry, I'm behind on my studying. I'm gonna have to like come back.
3 to 4.
It's okay. This is actually pretty straightforward. Like
4, 5, 6. All right.
It's just saying.
I'm comparing.
Like if there's 3.
Oh, sorry.
You're fine.
I put comparing 4 to 4 and 3 to 3 that I counted, and you don't do that. So it is 6.
Yeah.
Okay, 8. I have 27.208.
Yeah, that's what I have.
The largest, 53.158.
Yeah.
Okay, test for equal variances is satisfied for these data. I put true.
I said true.
Yeah. And then I construct Q's. And they looked like they were normal. Do you have true?
Yeah, they were.
Okay.
I have true.
Okay, and then 12. 0.309 without the
I
sock.
have that as well.
Okay. And the test statistic is because the p-value to the area, the right or the left. That was a weird question. Does that mean on the chart?
Yeah. So I don't know why, but so one of my husband's classmates actually said that it's just always going to be to the right for some reason. Like the F statistic is always to the right of the p-value. And I'm not sure why, but that's just how it is.
Okay, so it's right.
Yes.
Okay, 14. Okay, we examine the calories. And I put the first one that the assumptions had been met. It's safe to assume each group comes from a normally distributed population, and we can also assume that the variances are equal.
That's what I have as well.
Okay. And okay, we're running a ANOVA test for the, yeah, is it the calories in hot dogs?
Freedom.
Yeah, it gives you that. So I have the fourth one. It's sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than the other type.
Yeah, I have that.
Okay. And then 16, so we're doing the sodium levels, and I put the third one. I wasn't sure because that one QQ plot for the poultry was really kind of weird looking. So do you have
actually the first one on this one?
Okay.
Did it based off of what I saw on the plots.
It's okay to assume that they are normally and variances are equal, huh?
Yeah.
Okay.
I feel like if the plots even somewhat resemble a close pattern, it's probably okay to assume. Because to me, they look like up and down a little bit, but they still like follow somewhat of a pattern. So I'm like, all right.
Okay, the p-value for the poultry, let's see, for the test. I have 0.179.
I have that as well.
Okay.
Nice.
I was looking at this and forgot I rounded up.
Oh, yeah.
Okay, and then the next one, I did the fourth one. I have sufficient evidence to claim that at least one of the hot dog types has a different mean sodium level than another type.
So it would actually be we do not have sufficient evidence just because the p-value is greater than the level of significance.
Okay. Okay.
Let's do it.
Go ahead and submit. See how we did. It's thinking,
Wow.
it's thinking.
Submit, submit, submit.
Yippee skippy. Well, thanks for clarifying a couple of those things.
Yeah, this was actually a more straightforward one that I was like, okay.
Yeah,
What I'm doing. All right.
All right.
Well, happy Halloween, guys.
Thank you. Happy Halloween.
Have fun.
Have fun.